Can we trust artificial intelligence? Experts emphasize that artificial intelligence technology itself is neither good nor bad in a moral sense, but its uses can lead to both positive and negative outcomes. With artificial intelligence tools increasing in sophistication and usefulness, people and industries are eager to deploy them to increase efficiency, save money, and inform human decision-making. But are these tools ready for the real world? As any comic book fan knows, with great power comes great responsibility. The proliferation of AI raises questions about trust, privacy, and safety, and there are few settled, simple answers. As AI has been further incorporated into everyday life, more scholars, industries, and ordinary users are examining its effects on society. The academic field of AI ethics has grown over the past 5 years and involves engineers, social scientists, philosophers, and others. What does it take to trust AI? To trust a technology, you need evidence that it works in all kinds of conditions, and that it is accurate. We live in a society that functions based on a high degree of trust. We have a lot of systems that require trustworthiness, and most of them we don't even think about day to day. We already have ways of ensuring trustworthiness in food products and medicine. AI is new and fresh and different, but there are a lot of common best practices that we can start from. Today, many products come with safety guarantees, from children's car seats to batteries. But how are such guarantees established? In the case of AI, engineers can use mathematical proofs to provide assurance. For example, the AI that a drone uses to direct its landing could be mathematically proven to result in a stable landing. This kind of guarantee is hard to provide for something like a self-driving car because roads are full of people and obstacles whose behavior may be difficult to predict. Ensuring the AI system's responses and decisions are safe in any given situation is complex. One feature of AI systems that engineers test mathematically is their robustness, how the AI models react to noise, or imperfections, in the data they collect. If you need to trust these AI models, they cannot be brittle. Meaning, adding small amounts of noise should not be able to throw off the decision-making. A tiny amount of noise, for example, something in an image that is imperceptible to the human eye, can throw off the decision-making of current AI systems. For example, researchers have engineered small imperfections in an image of a stop sign that led the AI to recognize it as a speed limit sign instead. Of course, it would be dangerous for AI in a self-driving car to make this error. When AI is used in social situations, such as the criminal justice or banking systems, different types of guarantees, including fairness, are considered. What are the barriers to trustworthiness? Though we may call it smart, today's AI cannot think for itself. It will do exactly what it is programmed to do, which makes the instructions engineers give an AI system incredibly important. If you don't give it a good set of instructions, the AI's learned behavior can have unintended side effects or consequences. For example, say you want to train an AI system to recognize birds. You provide it with training data, but the data set only includes images of North American birds in daytime. What you have actually created is an AI system that recognizes images of North American birds in daylight, rather than all birds under all lighting and weather conditions. It is very difficult to control what patterns the AI will pick up on. Instructions become even more important when AI is used to make decisions about people's lives, such as when judges make parole decisions on the basis of an AI model that predicts whether someone convicted of a crime is likely to commit another crime. Instructions are also used to program values such as fairness into AI models. For example, a model could be programmed to have the same error rate across genders. But the people building the model have to choose a definition of fairness. a system cannot be designed to be fair in every conceivable way because it needs to be calibrated to prioritize certain measures of fairness over others in order to output decisions or predictions. Transparency and explainability. Today's advanced AI systems are not transparent. Classic algorithms are written by humans and are typically designed to be read and understood by others who can read code. AI architectures are built to automatically discover useful patterns, and it is difficult, sometimes seemingly impossible, for humans to interpret those patterns. A model may find patterns a human does not understand and then act unpredictably. Scientifically, we don't know why the neural networks are working as well as they are. If you look at the math, the data that the neural network is exposed to, from which it learns, is insufficient for the level of performance that it attains. Scientists are working to develop new mathematics to explain why neural networks are so powerful. There is an active area of research in explainability, or interpretability, of AI models. For AI to be used in real-world decision-making, human users need to know what factors the system used to determine a result. For example, if an AI model says a person should be denied a credit card or a loan, the bank is required to tell that person why the decision was made. Uncertainty measures. Another active area of research is designing AI systems that are aware of and can give users accurate measures of certainty in results. Just like humans, AI systems can make mistakes. For example, a self-driving car might mistake a white tractor-trailer truck crossing a highway for the sky. But to be trustworthy, AI needs to be able to recognize those mistakes before it is too late. Ideally, AI would be able to alert a human or some secondary system to take over when it is not confident in its decision-making. This is a complicated technical task for people designing AI. Many AI systems tend to be overconfident when they make mistakes. Would you trust a person who lies all the time very confidently? Of course not. It is a technical challenge to calibrate those uncertainties. How do we ensure that a model has a good uncertainty quantification, meaning it can fail gracefully or alert the users that it is not confident on certain decisions? When people encounter AI in everyday life, they may be tempted to adjust their behavior according to how they understand the system to work. In other words, they could game the system. When AI is designed by engineers and tested in lab conditions, this issue may not arise, and therefore the AI would not be designed to avoid it. Take social media as an example. They use AI to recommend content to users, and the AI is often trained to maximize engagement. It might learn that more provocative or polarizing content gets more engagement. This can create an unintended feedback loop in which people are incentivized to create ever more provocative content to maximize engagement, especially if sales or other financial incentives are involved. In turn, the AI system learns to focus even more on the most provocative content. Similarly, people may have an incentive to misreport data or lie to the AI system to achieve desired results. There is a lot of evidence that people are learning to game algorithms to get what they want. Sometimes, this gaming can be beneficial, and sometimes it can make everyone worse off. Designing algorithms that can reason about this is a big part of the research. The goal is to find algorithms that can incentivize people to report truthfully. Misuse of AI. You can think of AI or computer vision as basic technologies that can have a million applications. There are tons of wonderful applications, and there are some bad ones. Like with all new technologies, we will learn to harvest the benefits while avoiding the bad uses. Think of the printing press. For the last 400 years, our civilization benefited tremendously. But there have been bad books too. AI-enabled facial recognition has been used to profile certain ethnic groups and target political dissidents. AI-enabled spying software has violated human rights, according to the UN. Militaries have used AI to make weapons more effective and deadly. When you have something as powerful as that, people will always think of malicious ways of using it. Issues with cybersecurity are rampant, and what happens when you add AI to that effort? It's hacking on steroids. AI against humanity. When people think about the dangers of AI, they often think of Skynet, the fictional, sentient, humanity-destroying AI in the Terminator movies. In this imagined scenario, an AI system grows beyond human ability to control it and develops new capabilities that were not programmed at the outset. Experts continue to debate when, and whether, this is likely to occur and the scope of resources that should be directed to addressing it. University of Oxford professor Nick Bostrom notably predicts that AI will become superintelligent and overtake humanity. Science's researchers are less convinced. People will try to investigate the scenario even if the probability is small because the downside is huge. On one hand, we have these novel machine learning tools that display some autonomy from our own decision-making. On the other, there's hypothetical AI of the future that develops to the point where it's an intelligent, autonomous agent. It's really important to keep those two concepts separate, because you can be terrified of the latter and make the mistake of reading those same fears into the existing systems and tools, which have a different set of ethical issues to interrogate. Research into avoiding the worst-case scenario of AI turning on humans is called AI safety or AI alignment. This field explores topics such as the design of AI systems that avoid reward hacking, which is behavior that would give the AI more points for achieving its goal but would not achieve the benefit for which the AI system was designed. An example from a paper on the subject: if we reward the robot for achieving an environment free of messes, it might disable its vision so that it won't find any messes. Others explore the idea of building AI with break glass in case of emergency commands. But superintelligent AI could potentially work around these fail-safes. Many humans in the loop. Some AI systems automate processes whereas others make predictions. When these functions are combined, they create a powerful tool. But if the automated decision-making is not overseen by humans, issues of bias and inequity are more likely to go unnoticed. This is where the term, human in the loop, comes in. Humans and machines can work together to produce more efficient outcomes that are still scrutinized with the values of the user in mind. It is also beneficial when a diverse group of humans participates in creating AI systems. While early AI was developed by engineers, mathematicians, and computer scientists, social scientists and others are increasingly becoming involved from the outset. These are no longer just engineering problems. These algorithms interact with people and make decisions that affect people's lives. The traditional way that people are taught AI and machine learning does not consider that when you use these classifiers in the real world, they become part of this feedback loop. You increasingly need social scientists and people from the humanities to help in the design of AI. In addition to a diversity of scholarly viewpoints, AI research and development requires a diversity of identities and backgrounds to consider the many ways that technology can impact society and individuals. However, the field has remained largely homogeneous. Having diverse teams is so important because they bring different perspectives and experiences in terms of what the impacts can be. For one person, it's impossible to visualize all possible ways that technology like AI can be used. When teams are diverse, only then can we have creative solutions, and we'll know issues that can arise before AI is deployed. Thank you so much for watching. We hope you enjoyed this video and found it helpful. If you did, please don't forget to give it a thumbs up and subscribe to our channel for more content like this. If you have any questions or comments, feel free to leave them in the comment section below. We love hearing from our viewers and will do our best to respond to every message.